The primary objective of research is to make as accurate of inferences as we can. Inference is simply a fancy term that means rendering a conclusion based upon available evidence. And so what we do, of course, in research is we conduct a study and attempt to extrapolate those studies' findings to the population of interest that we've defined beforehand. To the extent that our study's findings comport with reality, what's actually happening in the world, then we make a correct inference. And there are two ways to do that, and those are depicted in green here and on this grid. And then to the extent that our study's findings do not comport with reality, then we have some errors, and those are depicted in blue right here in this grid. So reality is, remember, we can't access that directly. We have to conduct a study and then try to make reasoned conclusions about reality based on that. So that's why I indicate here what God only knows, because it's just a reminder that this is all hypothetical because we don't really have access to what is going on. We have glimpses, and we can get some accuracy, of course, but as far as the full picture and certainty, that is what we do not have in science, and it's okay to freely admit that. Okay, so let's talk about the different kinds of inferences we can make. Let's start with the quadrant here. This is when our study yields significant findings. So we run our t-tests, our ANOVA, regression, or correlation, and we get a significant effect. In reality, let's say, that effect is there. So our IV is impacting our DV in the way that we thought. And so that is a correct inference, and it's the most happy place to be on this grid, is in this quadrant, because we found a significant a result, which is great for publishing, and it is real, and so that's great. Now remember, we don't know for sure if it's real or not, and so this extends a little bit beyond this discussion, but I think it's important to just note briefly that the way that we that we build credence in a finding and build it on its trustworthiness is to replicate it in other samples in the population, and make sure that it's not a fluke or a type 1 error, this quadrant right here. Okay, so that's how we can build trust in the finding and understand if the finding is robust across different kinds of samples. So replication is really important, as some of our readings were indicating here in this class. All right, so let's talk about type 1 error now. Our study finds an effect, significant stat analysis, but in reality, the effect doesn't exist. So our IV does not impact our DV. And so this is like a false positive, and it's an incorrect inference, of course. And there are some factors that play into this. Probably the primary one is a confound. And a confound just means that instead of your IV impacting your DV, there's another variable that's doing that, but it makes you believe that it's really your IV. And so that is, it's kind of like tricking us into thinking that usually it's a variable correlated with our IV, but not the IV itself. And so we're confused as to the causation there. That's one way of thinking about type 1 error. And there are other ways as well, but that go beyond the scope of this discussion. But it's important to keep those things in mind, because people at conferences may ask you, you found this significant effect, but what if it was really this other thing that was operating? And we can think that through and have that conversation. It's totally good for science, and it's good for us as critical thinkers too. All right, so let's move down to the bottom left quadrant. This is when our study finds no effect, no significant t-test, ANOVA, etc. But in reality, this effect exists. So perhaps it was a small effect and we didn't have enough n size, and or maybe our measures were not as precise, so we weren't able to pick up that small effect. Maybe we had range restriction issues, and therefore we didn't find this effect. So if you find no results and you were expecting to, there are some things to talk about. And in your 2YPs, I'll be looking for this in the discussion sections, both type 1 and type 2. If you found an effect, is it the case that it could be something else that was impacting the DB? Just to show your learning and show that you're thinking it through. But if you found no effect, maybe it was a type 2, and so you go look through your variances and see if they were wide enough, look at your reliabilities of your measures, etc. Because this is an important skill. If you are doing research later or consuming the research, maybe you have a client who needs you to look up some things, conduct a study, and then report out, and maybe there's no effect and they ask why. Well, you have a few tools that you can pull out when you believe that you're in this quadrant. All right, and finally we have the last quadrant, and that is that there's no effect in reality, and our study rightly said there was no effect. And so in that case, our theory must have been wrong, and so we need to go back to the drawing board, think about what's really going on, and then come up with a new hypotheses and new propositions to test and advance the science in a little bit of a different direction than what maybe we had originally thought. All right, so this is the basic framework of what we do, and I find it very helpful just to think about which quadrant I might be in and how to talk about that with colleagues and with clients with on your 2IPs maybe, for example. So hopefully that was helpful, and just thinking through type 1, which we note as alpha, of course, and type 2, which is beta, and the inferences that we make that are either correct or incorrect on the basis of our study's findings.